Assalamualaikum warahmatullahi wabarakatuh. Selamat datang di channel yang membahas seputar penelitian dan publikasi ilmiah, khususnya untuk para akademisi dan praktisi di bidang penelitian dan publikasi. Sebelum kita masuk ke materi berikutnya, silakan di subscribe dan like. Dan jika ada pertanyaan, bisa menuliskan di kolom komen di bawah.
Honorable Director Professor Shivaji Bandyopadhyay, respected faculty members, IEEE Branch Counselor, and HOD, distinguished speaker Dr. Evijal Abdul Kadir, and my dear students, good afternoon to all. A very warm welcome to the second virtual lecture meeting of IEEE Antennas and Propagation Society Student Run Chapter at National Institute of Technology, Silchar. Worldwide spread of COVID-19 has pivoted us from in-person to digital. Virtual events present a new opportunity to overcoming the hurdles of social distancing and engaging resource persons as well as the audiences around the world. We thank IEEE SBC NITS for grabbing this golden opportunity for inviting Dr. Evijal Abdul Kadir, Universitas Islam RIAU, Indonesia, in the lecture meeting. We express our gratitude to Dr. Evijal Abdul Kadir for accepting our invitation and agreeing to stream his valuable talk online from Indonesia. Dr. Kadir, now it's your turn. All are waiting to hear from you.
Thank you, Dr. Banani, for your times. And first of all, good afternoon to all of you. And I would like to say thank you very much, especially National Institute of Technology, Silchar, for inviting me as a speaker for this afternoon discussions. And thank you for Director of NIT Silchar, Professor Shivaji, for your chance to me to share the sharing session to all of professor, the dean, head of departments, doctors, and all the students that I can't say one by one, all of you. So hopefully this afternoon's discussion will be beneficial for ours, and in the future we have future collaboration in terms of our field. So I would like to say my presentation this afternoon. All right. This afternoon session, I highlight the topic about the beyond 5G and 6G for the future wireless communication, especially. What is the application and challenges for the B5G and 6G? So again, thank you very much for NIT Silchar. So this telecommunication systems and as we know, for the a few decades before is 1990s, 2000, 2010s, the very significant changes. As 1990s, only kilobytes data rate, data transmission, but till a few years, then now is gigabit data rate. So in the future, expected in 6G, sixth generation of mobile or wireless communication, terabit per second. This how is the technology is going on. So what is the challenges, and what is our part to contribute on our research later on. So I am Evijal Abdul Kadir from Islamic University of RIAU, or Universitas Islam RIAU, Indonesia. So this I introduce my university. As you know, this Indonesia maps. This actually our is not in capital city of Indonesia, Jakarta. We are in the Sumatra Islands. This capital city is in Java. This Jakarta. So we are here in central of Sumatra, actually close to Singapore and Kuala Lumpur, Malaysia. only 40 minutes flight to Singapore or Kuala Lumpur, Malaysia. So this our capital city of Riau. The Riau is the state, and the capital city is the Pekanbaru. So this Singapore about 40 minutes flight. So we are here. So this actually I already searched. Silchar is about here. So this our here. So we go to the Myanmar, Thailand, and Malaysia. So we go. So you can go transit on Malaysia because no direct flight. So this our university. Part of scan. This our entrance. This main building. Our administration. Temporarily, I am here. I am in charge in the research institute. Actually, the research management center to accommodate, to provide research to all of lecturers in our campus. Also, the community service. So this our campus, 55 hectares. So this the main building is I showed to you just now, and Faculty of Engineering is here. So we have several others building in 55 acres. For your information, our university established 1962. So we just celebrate the 4th September as month. And we have 9 faculties and 1 postgraduate studies, 43 departments. We have about 800 faculty staff, which is professor, lecturer, and 500 supporting staff. The supporting staff. Till now, we have 26,000 number of students. Then we already have a top 100 among 4,000 universities in Indonesia, or in terms of the research performance. So in Indonesia, there is about actually 4,500 something higher education. It's not university, higher education. So we are top 100, which is 72 ranked in the research performance. In overall, we are top 300 on rank in Indonesia. This introduction for my university. So this afternoon talk, we are going to talk about, I'm not going just a lecturer, but we just sharing session, which is we are in the same field as I know. In terms of this field, as I know, this invitation from IEEE APS, Antenna Propagation Society, also Communication Society. So we are in the same field in terms of the communication, which is antenna, radio, about sensing later on. So how this technology for the future, I will touch a bit about future trend of technology as generals. So beyond 5th generation or 5th generation, as we know, before that, in 2000, there is 3G. Then after that, we know 3.5G, some say 3.9G before our 3.9G or pre-4G, and going to the 4G. Similar, some people get Zube. Now is 5G. Before going to 6G, there is something, let's say 5.5G or beyond 5G. Some people say it's B5G, beyond 5G. What is the advance expected before going to 6G? Because the 6G expected to next 10 years, which is 2030. So there is 25, let's say, beyond 5G, how the improvement, the changes of the technology. I a bit touching about artificial intelligence, because the 6G involved on AI. Because the network is very smart, so involved in artificial intelligence. Some analysis is not pure about the analog system or manual system. So AI is in 6G wireless network application. Then IoT, one of the technology. So because the sensing is everywhere. The next 5-10 years, everywhere there is sensing. And how the sensing and 6G mobile or wireless communication is other, how sensing is need backbone or communication. How the 6G, our wireless, especially our mobile communication, data communication, to have a sensing system. And also it's not only IoT but IoE, Internet of Everything. The next is later on, now people talking about IOST, Internet of Space Thing. It's not only of things but the space, going to the space. And the last part, maybe we're talking about 6G wireless network challenges. How the challenges, later I will show some of the challenges, especially in our part, maybe antenna and RF part. So this, I saw the background or the introduction on this talk is top 12 technologies in the future coming. This survey that the next coming years, the 12 technology is become future technology, which is sensor and cameras, Internet of Things, which is sensor and camera, and high-speed internet. People demanding of high-speed internet, especially mobile and video. As currently, also we are our conference, our seminar also going mobile and video, which is remote. I am from Indonesia, then remote to India, so I need high-speed internet to get a real-time communication. Other is AI, like sharing sourcing, drone, 3D printing is, but I concern is the two because very related to our data communication, which is mobile. Most is next communication is people going to wirelessly. Don't want to is wired. So I focus about this. So if we flashback a few years back, 2017, 3GPP, one of the group project partnership on the third generation, release standard 15, standalone, non-standalone, standalone, 16, 17. Now, and a few company going on the this focusing on this 5G and 6G, as we know, as Huawei, LG, and others company is focusing in this technology. This in 2021 become release 70s. If we see the distribution currently, 5G actually already commercial now. Although the research on 5G is not finished yet, but almost done, and now is a stage of the deployment or commercialization. Till now, 2020, only a few countries that already deploy, some country already trials, and we see 5G commercial already a few countries. So next coming maybe 4-5 years, already deployed in most of common country. So in our country, like Indonesia now is still 4G, so maybe a few countries. We see the distribution by 2020 now is the blue is only something like Europe, US, Australia. So expected by 25, the 5G already deployed in most of the country. So what is challenges? As we know, the 4G also take a few years to deploy to all the country. So the distribution of the coverage in terms of the adoption, 5G adoption in million. So now is 2020, about 100 millions adoption device till now. So by 4-5 years, by 2025, the trend very extreme, exponential, it's not exponential, keep increasing till 2025 expected is 1400 adoption, 1400 millions of the device connected to the 5G coverage is 1400 million is not all the mobile phone is not. There is something sensing most of the device is sensor because everyone keep install sensing and in terms of the coverage by 2025 is expected is 40% of coverage. So the distribution. So we have to prepare how this 5G technology can handle the increasing, very significant increased number of the device connected, device adoption on the 5G. So as we see now is this initial 5G, this beyond 5G, extreme coverage. as we know, currently starting from the 1st G till maybe 4G, mostly the government only the land. But the beyond 5G, the expected is not only land coverage. They expect it only on the sky with the HAPS, high altitude platform. We install a high altitude platform on the sky, which is when you are going on board on the flights, we can communicate. Although currently some of the aircraft there is a provide Wi-Fi or internet, but later on there is something the internet access on the sky is something like our lands. So on the sea as well. Now only the sea near to the beach, near to the land, only covered by networks. But later on, they are only also covered, especially for the vessel, for the ship on the sea, a space as well. Because as we saw, the now is some research are going to the space, even tourism to the space. They are also willing to cover on the space. So this extreme coverage is not only the land, as well as the capacity. Data rate keep increasing. Yeah, data rate. This high extreme data rate and capacity, how the technology handle this demand, this requirement of technology. So the power efficiency will be important. Power efficiency transmission with the important. So in our research, maybe we had to design our radio frequency or part with very efficient radio access technology. Maybe we need to find new technology radio access very efficient. Spectrum efficiency, the power efficiency. This graph. So this the coverage is beyond 5G, and the frequency, the bandwidth is not only below 1 gig or 3 gigs, above 100 gigahertz. So then if we are cluster by metric, this just we need to know the user what is the requirement, the demand. If we are talking about autonomous driving, so the metric is about here, the delay less than 1 millisecond. So we have to provide the technology. If we are the car or vehicle with the autonomous driving, so need to provide very low latency or very low delay, less than 1 second. This multi-person video call like our now, multi-person, which is more than 1,000 people in the conference. So we have to provide 10 milliseconds. So why we do this metric? Because we want to know. We are talking about tactile internet, augmented reality. So this year, they need more than 1 gigabytes is capacity. So this actually how our technology can provide about this. This actually the application. So we know the requirement every application like monitoring and sensing maybe it's not significant, requires low delay, maybe 1 millisecond still acceptable because the sensing only send the data. So we know about that. So, yeah. Then we go to the for the next beyond 5G and 6G, we go to the high frequency. As we know, the low frequency, yes, there is advantage on the below than 1 gigahertz. They can give up coverage. Yes, low frequency, the advantage is coverage, but the disadvantage is capacity, and especially below 1 gigahertz, very low capacity. As we see, this base station, if we go to 1 to 6 gigahertz, the capacity is increased. The capacity increases, but the coverage is less. And we have to go to the high frequency. And the 5G, beyond 5G and 6G, even maybe next is 7 or 8 generation, we have to go to higher frequency because the low frequency mostly occupied in the low frequency, especially below 1 gigahertz. Many applications like broadcasting, other communication, and etc. So we have to go to high frequency. although the limitation is covered, but we have to increase the capacity because of the capacity. Later we see how the user increasing capacity in very significant. So this example, some of country, actually all the spectrum will support 5G, especially for the gigahertz. This Europe 3 to 4 gigahertz, US, China, the spectrum. So depend on our country, we have to check our country regulations because every country they have telecommunication standard. So they are, every country they have a rule. So we know which band our country, and in general, of course, we have to know also in general how the common, especially ITU, standardize the spectrum in the global. So in the over than 20 gigahertz, the Europe play on this spectrum 24 and 26, or even 28. So why we need to know this? Because when we design, let's say when we design an antenna, so we need to know the specification. So I want to design an antenna, let's say 26 gigahertz, or this qualified by this country, or general. So let's say we want to design antenna in 20 gigahertz, which is no other country use, is our design is useless. So we have to know the standardized is globals. Now ITU is a telecommunication union already standardized in generals in global. So we have to know the rule as well as our country rule. So we like our design is utilize apply to is commercial. It's not only just design, it's not just only research, but commercialized. So this figure how country adopt the frequency band. So this flashback as well, the 5G. The keyword is a very high data rates, mobility up to 500 kilometer per hour, high data rate, even 10 gigabits per second, very high capacity, massive numbers, long battery life time, even 6G expected. There is no battery. The device will utilize other energies. Yeah. So this under research how the energy is utilized. Very low latency, less than 1 millisecond reliability. So the just our imagine how before in 1990s, let's say GPRS, how low in only kilobits, yeah, 56 kilobit per second. So in order to download, let's say one movie 800 megabyte, need 36 hours. 36 hours. Then going to 3G and 4G now is let's say one movie which is one let's say 1 gigabytes movie, only 43 seconds. 5G only 1 second. So how the technology very fast, only 20 30 years, very tremendously significant improvement. So we expected 6G only less than 1 second to download this 1 gigabyte movie. So the flashback, the evolution of the technology, especially in mobile and wireless communication, 1980s, let's say, we still analog, 90s, already digital, 2G, then 20, 3G. So now we are going here, the 5G and 6G, 2020 and 2030. Resolution of the social issue, human-centered and because the 6G generation or beyond 5G is not only provide the communication to the like our communication face to face. Furthermore, it's not involved on society as well. So as we know, the industrial revolution 5.0 is not 4.0. 4.0 is okay. Industrial revolution, IR revolution. So 5.0 is social. Yeah? Social, how people meet together with the communication. So we are focused in the this 10 years, 2020, 2030, focusing the 5G and 6G. So the flashback is the 1G we still use technology FDMA, frequency division, and going to the second G, TDMA, time division. We go the third G, code division or CDMA. Then we go to 4G or DM or massive MIMO. So the others are multiplexing. So this 5G massive MIMO and 6G, some research say need involve AI because they need to smart involve artificial intelligence, machine learning, and deep learning to make a smart network. So we go for here. So beyond 5G expected 20 gigabit per second enhanced in release 16. So and next 6G expected to terabit communication. Okay, this some of the research or the rule as we see just now we saw 3GPP, now is 5G project partnership. So this European research initiative industry effort. It's not only academician as our academician in university on research institute, company also doing on research on mobile communication, like mobile communication company. So they are also doing this extra how the communication going to their product. So ITU also got standard, especially this global standardization, 6G vision requirement. So in this 5G evaluation at the design, so 6G, we can see the document how the ITU standardized, because we have to know the standardized in terms of the bandwidth, the frequency, how the evolution and expected. So 5G and beyond and 6G or pre-6G or 2030 become the 6G. So we have to check as well the standard starting from release 15 till 19. How? Because we need to check standard and relate our research activity in them. This comparison about 5G and 6G. As we know, the operating most of the research already now in provide with the 6 gigahertz antenna, 26, 28 gigahertz antenna for 5G and beyond 5G, and 6G expected 1 terahertz antenna. So some research already started proposed on the terahertz giga bandwidth or terahertz antenna. So one of our research can focus on the terahertz, how the terahertz frequency band adopt in our 6G. So the uplink 10 gigabits for 5G and 6G is 1 terabit per second. The downlink is 5G 20. So I circle in the red how is current 5G the mobility up to 500 kilometers per hour. We see the if we go to Japan, the Shinkansen, if we go Europe in Eurotrains and others, fast train in China as well. They are very fast, high speed train up to 500, 400 and 500. How this technology still can communicate? Very low latency, 0.5 milliseconds, even 6G expected 0.1 millisecond, very low latency. How is this? Because autonomous car autonomous car in 100 kilometers per hour, the speeds 0.1 second already a few meters. So if the distance from car to car about 10 meters, they need very low latency to avoid the accident. Okay. So why we need very low latency? Processing time in even nanoseconds, 0.1 millisecond or 100 nanoseconds is 10 nanosecond. So very low. So 6G as well, because need to smart network, so the other artificial intelligence integration is fully. Now 5G only partials. So as we know now, AR, augmented reality, and VR, visuality, that most of the video game on some of education they use AR and I. Next is XR, extended integration, extended reality. So these specs, haptic also, haptic communication, automation integration in industry. So the challenges is our next, even is beyond 5G, how to achieve this 10 or 20 gigabit per second the data rate of the communication. So the EMBP, enhanced mobile broadband, maybe we can take a part on the network or right part. We can go to this one, machine type communication, and MTC. So ultra low latency. This very low latency. In the 6G, 0.1 milliseconds, very low latency. The delay very low. So how the integration in adopts this 5G to the 6G, because 5G is 6G is involved together. Yeah, it's not separate. It's the it's not something like 2G and 3G digital, and 3G we use the video. There is a bit gap within 2G. There is data, and 3G is involved on video, but this one similar. Then next 6G, everything is extreme high data rates and capacity, extreme coverage, extreme low energy and cost, even the device from battery charging. Expected 6G is no battery in our mobile phone. So where energy will come from? There are very some research talking about harvestings. Actually, in our environment is all energy. Such as solar energy, even our light contribute energy, something like that. So the expected is a free battery. There's no charging, no more battery. So they are harvesting from environments. Extreme low latency, less than 1 millisecond is 0.1 second. Guaranteed QoS, extreme high reliability, quality of service in terms of throughput, delays, packet loss, everything is, there is no loss. We are talking about now is very clear. Then massive connected device, this 10 million per kilometer squares. Yeah, because increasing number of device, especially in sensor, there is very extreme. Sensing capabilities, high precision positioning. Okay, maybe I speed up because many slide. So AI, touch speed, artificial intelligence. As we know, artificial intelligence is a simulation of human intelligence processed by machine, especially computer system. This process including learning. So how our network, essentially communication network, is become a smart network. So as we see artificial intelligence in earlier days, just artificial intelligence, next become machine learning. They are learn in the previous history how they are the previous the behavior of the system, then become a deep learning, because in the complex system we have to go to dynamic learning. Maybe our friends from AI can involve together to how to make it our smart network system. So this is one example how communication, AI involved in our communication, our big data, because every sensor, every communication contribute data. Nowadays, everyone, every system they record the data, so become big data. So going to our networks, there is too many data. It's not too many, very huge number of data. So need to analyze. It's not enough only our smart system in network. Need to involve further technology like AI. This one is a deep learning, consists of a few hidden layers and gated identify the data decision. This input, process, decision. So this is another example of AI. So just a touch bit about the 6G and beyond with the quantum machine learning. Now, one of the technology, some people, as I know, MIT, I see there is one group research in quantum machine learning, also related to our networking system. So I don't discuss each one because limited of time. So then this is one example, very complex architecture on the 6th generation later on. as we see just now in earlier, it's not only a land covered network, it's not only land, also the space with the HAPs, yeah, is skies, the sky with a high altitude platform or unmanned vehicles. So in this space as well, there is a shuttle space. Is later on the space station ISS to the Earth is very frequent, so we need to cover the network. Also the sea just now, and the ship, ocean, and as well as a submarine. So how our networks, our communication to penetrate under the sea, yeah. One of the constraints now is our networks going to the water, they are reflected. Although underground, under submarine or under seas, there is because of water is absorbed. So how our technology is, maybe we can set base station a platform under the sea, maybe because it's submarine is not now is only for the Navy. Later on, maybe people we are tourism, underground tourism, underwater tourism maybe. So there is many application. Is one hotel in the Dubai. There's a set up hotel is under the sea hotel. So this we have to the requirement, the demand. So as well as our house, the smart appliance is not only currently maybe our house connected to the network only CCTV. Most of the house, most of the home, they have a CCTV on connected network. Next one is not only CCTV. Every home appliance, like TV now already connected, smart TV. So later on, maybe our plates, our washing machine, our coffee maker, our rice cooker, everything is connected internet. And contributor, we have to adopt. Adopt is everything. So the scenario, how big number, the increasing is not only communications like our mobile phone, our laptop, but more than on sensing. So this IoT, I touched a bit about IoT, Internet of Things, because one of the focusing the use of the networks is a sensor. Internet of Things is one of the sensor. Although Internet of Things is everything is connected internet, but sensor IoT most adopted by sensor. Every sensor need connected to the network. So industrials, our house, our hospital, vehicle, everything is connected to the internet. So this just definition of internet. I just highlight only this one. Sensor, the term of IoT is encompassing various platform, application, and technology. Sensor and actuator connected by network to computing system. This contribute to data. Let's say sensing system for the environment, the connected network, they give information about the environmentals. So this by 2020, this research a few years ago. 2020 now is 2020. There is 200 billion devices connected to the internet. Maybe 10 years ago or 20 years ago, maybe our mobile phone, only mobile phone and laptop, maybe let's say in our office, maybe PC connected to the internet. 10 years ago or 5 years ago, already connected our tablets, our vehicle with the, now we can track our vehicle, where the location with the GPS, sorry. So by 2020, there is 200 billion device connected. Our home now, now our CCTV, TV and others, home appliance and the office, photocopy machine connected to the internet, our projector connected to the internet. So by next 10 years, 2030, the increase very significant, exponential, 700,000% increases. So this we have to adopt. Is not because every things, every sensor requires a network. So we have to adopt how our network system accommodates the demand, the huge number of sensors. So the 5G IoT environable device, this how we can imagine. Fortunately, we can't see the signal, the spectrum. We can, if we can see spectrum, maybe we cannot walk. Everywhere is spectrum. A simple thing. If you have radio, broadcast radio, we tune frequency from kilohertz till a few gigahertz, let's say 10 gigahertz. There is all spectrum on the sky. So everywhere is spectrum. So how imagine spectrum is unoccupied. So this some survey of data. Now it's 2020. Only about 60 exabytes contribute the data. But the blue is with without machine-to-machine data, machine-to-machine communication, and with machine-to-machine data is about 62. So the exabyte in 2020, because the sensor contribute data every day, our communication even every day. We have posting on Facebook, Twitter, YouTube. We have chat, WhatsApp, Vibers, and other platform line. Everything is we contribute data. All this recorded. So by 10 years later, there is a 5,000 exabyte. There is exponential increasing number of data requirement because all of data, because just now 700,000 increasing of number of sensor connected to the internet or networks. So this 5,000 or 5 zettabytes. So very significant contribute. Why I need to show this? Because we are in the networking system. Although we are in antenna part, we have to design very high data rate antenna. For example, one of is a very massive MIMO antenna, let's say, and other technology. If we can find other antenna technology that can provide gigabit per second or terabit per second antenna is very good. So our challenges. Now later on we discuss on our challenges, high speed data communication, and just now I already mentioned as well, Internet of Everything. It's not only data, things, and process, but what is different? Internet of Everything is involved in people in the smarts. Okay, just a quick on this one. The application of the technology is we know now most of the network is application for the mobile communications. Now we go to video conference. Our mobile communication is not only for talking, but for tracking, for GPS. The next 6G expected is holographic communication. It's not only like our 3G and 4G, we can see our video, our picture, we can communicate video calls and everything. 6G expected is some of group already do research on holographics. How when we call someone, there is a holographic come out in our mobile phone. She is another group already starting research on this holographic. So this smart sensing or like IoT is other smart sensing. Is just not sensing is not only sense just now. They are only smart sensing, intelligent sensing. Let's say this our smartwatch. When we are running, they are you are running detect because they are detect on the movement, so they can scan, they can conclude smart sensing, and they get a summarize on our heads. So everything is need data, real-time data to the let's say our summarized medical, we got heart, they take everything, they need to inform the doctor immediately in the real time. So this need very fast network data communication. And another thing example is our CCTV now is just not only CCTV. It's not capture our the flow of the vehicle. It's not in the road. The KCC is not only view the but furthermore they do analysis. This type of the car, the minivan or van or truck or lorry. So the size of car they need to analysis. There is smart. Okay? So they only also do analysis. It's not only how fast the car is moving, but only the size of car. So they want to capture this analysis. Then because the CCTV involved on video, even now is the model or a camera or the type of camera very high definition. Even our smartphone, in earlier days, our smartphone probably only 1 megapixel maybe. The size, the resolution of camera now our camera is on a smartphone only at a 10 or 20 megapixel. There is a high resolution. When they are dealing about the higher resolution of video, there is absorb very high bandwidth, so need to high capacity or high data rate communication. So other things, everything is camera, so very high data rate required. So this one of the sample application of face recognitions. So most of the city, they call a smart city, they install a camera as a smart to monitor the movement of people, especially now in the smart city. One of the country implement, if you are positive, let's say you are in the positive of COVID, so we capture your image. So we are the city they were scan, monitored by public CCTV, every CCTV. If you go without permission, so we capture. So another thing, I was talking about something like Dubai or Europe, London. So they are implement smart city. Let's say I am in once we go to as tourism to Dubai, in immigration they capture our image with the immigration camera. So your image will record. Although the government, the immigrations don't take your mobile number, they know. When you go to the shopping complex, there is camera, capture your image, or you are in the shopping complex. When you go to the public, there is public CCTV, or you are in the public CCTV. They are very easily to tracking you. Although you off your mobile, you don't connect to your network. So now we cannot avoid this one. We cannot avoid our privacy. We don't have no more privacy. When go to hotel, there is CCTV on the bed. Even the hotel is many camera. So it is very easy to capture our image and locate you. And some application, if you go, someone do criminal, let's say, so very easy to track you. So, okay. This is one application. All those things related required high data rate because need to the real-time communication. So another application is in education. There is now later on 3.0 education, which is advanced communication, especially now in our pandemics. Need a long distance education, long distance learning. So real time or something lecture, online lecture is not enough. You need innovative and some more holographic teaching and learning. So the teacher can explain with the holographics, with the 6G holographic teaching and learning. So this for your information, I working with one of the group in the Glasgow University. So the implementation application with the 6 generations or beyond 5G, beyond 5th generation on the health course application, health course. So we take case on COVID-19 patient, just for your information. We go need, because the information from the patient going to cloud computing need involve on the high speed data rate, because we need real time. It's not only one patient, there is let's say 100 or 1,000 patients we need to submit data. So we working one of the group in the Glasgow University. So what is the challenges? As our discussion in earlier, spectrum below than 1 gigahertz already occupied most of the others application. So we have to go to beyond high spectrum. Some people said spectrum more above than 100 gigahertz to occupy what they beyond 5G and 6G. So this, as we see, this terahertz spectrum. So we have to go this spectrum because the beyond like say petahertz is not feasible to do a communication because very dangerous, like X-ray over there. So because very dangerous, the spectrum is very dangerous. So also contrast. If we go to high spectrum, is it okay to our health? even 5G, some of the group, some of the country, they ban 5G because concern about the human health, So we have to do, maybe we go to other group research, maybe interesting on the impact of high spectrum, especially terahertz, how the impact to human health is one of the focus the research. So we go, some people probably is above that 100 gigahertz spectrum, let's say 300 gigahertz spectrum. So this one of the spectrum is very important because we need capacity, high capacity. This one terahertz bands. So this micro here. So we go to millimeters. This petahertz is not visible because petahertz are the ultraviolet or X-ray, exahertz. So some most of the research expected on terahertz. So some of group already conduct research on terahertz band, especially antenna, how we design on the terahertz, because very narrow bands, millimeter waves. So how we conduct in this research on this spectrum. So picture radio access technology, okay. OFDM, orthogonal frequency diffusion multiplexing, diffusion multiplexing. So how our technology, now we go this ELTE, okay, evolve long-term evolution, new radio and RIAU. So in our fields, we can go to our radio part, our radio frequency. We can design transmitter or receiver. We can go to the antenna parts. We can go to the others part of the challenges to accommodate the sixth generation requirement. So there's a new expected OFDM with the extreme coverage, because the coverage we go to high frequency, the constraint is coverage, how we increase capacity in the coverage as well. So a new topology for the enhanced and MIMO, massive MIMO over there. So maybe we can design massive MIMO system. It's not only 64 by 64, maybe 120, 800, or even more. Very massive MIMO antenna with the high frequency for our research. How we do this and invoke AI. Maybe we invoke AI group. How to get a smart network. So a 6G will be a combination of technology and enhance through to bring big again. So 6G is not only like let me say it's 2G or 3G, just a network to accommodate the communication. In 2G or 3G, if we can do a communication, let's say a video call is enough. Is 6G is no more beyond over there. So involve a combination AI over there, a smart network system over there. So we have to accommodate, become a big deal, big gain over there. So another thing is wireless LAN, local area, so increasing. As we know, the evolution from the Wi-Fi or wireless local area networks is from AB, AG, and AB. Next, also going to terabit per second. Maybe if you know, the foremost one is 802.11b. It is IEEE standard. Very famous, just last time only 10 megabit per second. Now keep increasing. ACAD now, if we next beyond, we going to also to terabit data connection in our local area network, in our campus or Wi-Fi system. This need to import also how our design our system and network, maybe antenna and others. So this 6G just challenges. I highlight this one, cell-free MIMO antenna. Although this many quantum communication, internet or bio nano things, I concern in this terahertz band communication. Terahertz, how our terahertz communication we design on the in terms of radio and antenna. Also cell-free massive MIMO means our mobile device become base station. like just now, like base station, not B, E not B. Next is no more base station, no more not B or E not B. The device, the mobile station is become a station. How this is called a cell free. Our mobile is become a base station. Yeah, they can, because it's not only pico communication, but femto communication. Like our base station, macro stations, micro station, pico station, femto station is very small cells. Then mobiles. There's another is intelligent communication environment. Very intelligent, very smart. Need involved to algorithm or smart system. So I like these three. Then the key features, I just go fast. Multi-band ultra speed transmission. There is terahertz bands, visible light. Maybe we can go explore how the lights become. Is not. Some people is light is communication via the lights. We use a light fiber optic, but it is a cable fiber optic. How the light radio over fiber, radio over bikes. So we use infrared or light as a media. So this energy efficient communication just now, batteryless or no battery, artificial intelligence involved over there, high security and privacy, very high security. So maybe our concern is wireless power charging is another group also concerned about the WPC, wireless power wireless PT, wireless power transmission. So we go over here, terahertz band and visible light, and there is a constraint in the terahertz because I am research most in some of antenna, although there is involved on healthcare and sensor, because I also involved on other project like healthcare and smart sensing. So my research is on antenna as well, how our terahertz propagation phenomenon, because if we go to high frequency, terahertz frequency beyond, so there is losses, spreading loss, because the high frequency absorption loss, especially the water and molecules. As we know just now, water is absorbed the frequency. How to avoid over that absorption loss, because high loss. There's challenges, submarine network, small scale mobility, micro Doppler effect. So actually, Doppler effect very effect to our spectrum, because human body movements, things movement, there is effects how we avoid the small scale mobility, non-light of science propagation. There is refraction, scattering, reflections, a multi-part. One of the issue on this high spectrum terahertz, a small scale and large scale fading. Yeah, how multi-part fading, even in the frequency gigahertz, there is multi-part fading. When objects, obstacles, there is the open area, and it's okay. In the pre-space, it's okay. It's less fading, multi-part fading, but like in the city where the crowded so many, there is multi-parts, especially the high spectrum. How is our technology to tackle, to handle these constraints on the terahertz? So next is visible spectrum holographic network. So images, we can see holographic our network. Now we don't know our receive network from the base station or E not B, we don't know either our in the cover or not. Later on, there is holographic spectrum in both microwave, visible IR, terahertz spectrum. So I summarize global trend wireless network in the picture, because the increasing number of mobile subscriptions, like not just 2010s, 5 billion, 10 billion, 2020 now is 70 billion next 10 years. So smartphone, machine to machine, especially machine to machine, because next feature, they very autonomous machine to machine communication. For example, now if you are going to the, let's say if I going to India or New Delhi or Singapore, I want to book a hotel. I have to go to book hotel by phone or by online. Next, there is a machine to machine. We have planned in the calendar. Let's say next month, 5 days I am going to Singapore. Let's say, so I put in our calendar. So my computer, my mobiles, automatics book the hotel is because very intelligent. Normally, if I go Singapore, where I stay, there's a book the hotel. In the hotel also, machine answer the booking. It's not no more people. So very smart machine communication. So this very smart traffic volume, as we discussed now, 5,000 exabytes per month. There's very huge traffic. So how we are, as our network need to hike data rates to accommodate machine-to-machine traffic, traffic per subscriber. So now, mostly in every month, let's say we subscribe 10 gigas. I think it's 10 gigabyte already, very big in currents. Next 2030 is not enough. 10, about 250 giga, because now maybe, for examples, for me, use of data in Monday, maybe I got online teaching, browsing, or chatting. Like now is I go online seminars. Every month most and operate is 10 gigabytes data subscriptions. So the next mobile phone is not only for my lecture, online lecture, it's not only my video call, it's not only my meetings, everything mobile phone is subscribed automatically. Books connected. Next 10 years, mobile phone automatically. Let's say in my house, there is copy makers connected to the internet. When I going back, my mobile phone automatic instruct to copy maker make a cup of coffee and other things. If my light in the home is not switch off in the day night, my phone automatics control the light. So it is automatics. So the increasing number data subscribes. So you can imagine in the Earth now, the 7 millions, 7 billion populations. So let's say 50%, 3 or 4 billion population subscribe 250 gigabytes. So how much the huge data so for our daily activity. So the challenges is Terahertz band communication. Maybe I speed up this a bit, few slides. No, system capacity. One of the how our this open problem. So our research challenges, fabrication and testing of the antenna array. So how our antenna array very small millimeter wave. How our design testing everything. Terahertz band antenna. To increase the capacity, routing protocols, real-time control algorithm, everything. Intelligent communication environment. So our networks need to be smart and intelligent. System capacity, low latency. So I don't discuss everything. It's one by one because time. Persistent artificial intelligence, network automation, the system latency, system management, reconfigurable transceiver front to end. So system capacity. So this. How our research to overcome this or to tackle this issue. Then ambient backstairs, Internet of Space thing is I mentioned just now, Internet IOST, Internet of Space thing. So it's not only our in the ground, in the earth, but the space also they got. System capacity, multi-band transceiver design in the radio part, maybe you can design multi-band with it's not only one band, let's say 100 gigahertz or 200 gigahertz, but multi-covered from the 100 gigahertz to terahertz, let's say. So spectral and energy efficiency, Internet of Nano Things, so everything in beyond quantum communication. So maybe our part in this area in the communication, let's say, or antenna RF or radio. So the last this extreme large bandwidth terahertz energy efficient. How create our system very efficient. It's not our previous base station need to get a high power, need to put something like Ocopite. The next, very energy efficient. Even if put a small solar cell, they can accommodate the power. Artificial intelligence, high security, and others. So these challenges, transceiver design terahertz signal generators. This some group already generate this design. How design transmitter and receiver for both in the terahertz system. Then this I got some of group. Okay, we are also working with the one of the group in the France, the Rennes University. So they do an antenna. So how this array antenna? See this example I adopt from others research group. How they accommodate like 100 gigahertz antenna. So this array antenna. So we can start. Maybe we can keep this. As a review, so how they do on the antenna. This one also, the array antenna, terahertz, source, so the how the MIMO antenna, the array antenna, MIMO antenna to cover in the terahertz band. So maybe we can do either the new materials, new methods, and others method to get a novel or new technology with a very efficient antenna design. So this is some example. So I conclude this discussion is actually 6G expected more than 100 or beyond 5G or 6G, more than 100 gigabit per second. So zero energy, something like batteryless, no battery, less than 1 millisecond, the latency, 0.1 millisecond latency. So scalable, very global coverage, even it's not only the land, as we mentioned just now, the sky, even the space, it's not only the sea, but under submarine, under the sea. It's not only the sea, on the sea, but under the sea. It's not only the sky, but on the space. So we have to, so many very large area of the research. How research our antenna, our spectrum can penetrate the water, that we can do base station under the sea. Let's say we put a base station waterproof, they put under the sea, because later on they are hotel under the sea. So they need infrastructure, they need communication. So last slide in my presentation, 6th generation 6G communication system expected to in terabit per second due to huge number of devices connected. Billion of devices connected later on in 2030. And sharing information. There are the sensor, everything is sharing information. Like now is our mobile phone, we got chatting, sharing information. Now device also machine to machine communication. So the challenges, this challenge to develop new technology in any aspect, either you, the smart system, the antenna, the RF transmitter, transceiver, everything's to provide good connectivity. Wireless communication is one of the technology mostly used because we are talking mobile. Is people are prefer on wireless, it's not wired. So high speed data rate and communication is radio system, antenna, access system. So these our challenges, how we tackle in our research, especially maybe we can collaborate and discuss further later on how we do. Maybe it's not big a portion, a small portion. Maybe we are focusing on antenna. Let's say we are focusing on radio. Let's say. So I think that's all. This afternoon discussion, just sharing to all of you. So later we can keep in touch and communication. So this my email. If anyone's inquiry, so you can send to my email here. Thank you so much. I beg to Dr. Banani for this session. Thank you so much. Sorry for the take much time in this presentation. I return back to Dr. Banani.
Thank you, sir, for the wonderful discussion. Audience, have you any question? Anyone from you?
Yeah,
Okay, if you, yes.
yeah. That was a very informative presentation by the professor. I would like to know the role of energy constraints in this 6G. I mean, beyond 5G communication.
Mhm.
What will be the role of energy constraint design, system design, and what will be the role of antenna design perspective in this energy harvesting scenario,
Mhm.
considering these applications, means IoTs and other things?
Yeah. All right. The constraint is because we have to design high frequency, especially above 100 gigahertz. As the high frequency, the constraint is the because the millimeter wave, very constant, or the multi-part, the parts. Uh, as we know, for example, now is satellite communication. They are working in the high frequency. For example, when the rainings, they are involved on the because the raindrop will affect the communication as well as the 6G and 5G. We have to go. We have to look high frequency because of the limitation, the frequency, especially below 1G or even below 6G. Now already occupied. Let's say 3.5G. So we have to go beyond. Let's say 26, even 26 now. 5G, some of country looking for the 26 to 28 gigahertz band. This the concern is the multi-pass because in the smart city especially, if we go to open area, it's not much multi fading. So we go to the smart city. So the idea is like this. The constraint is the parts, the noise, the interference. So how we design the smart antenna. So that's why the 5G and beyond 6G, the scale is not like BTS. Imagine like now, our base station or not B can cover 1 kilometer or 5 kilometers. And the beyond is cannot like that because they are very fast, but multi-parts. Beyond 6G, our it's not pico cells, maybe femto cell, which is covered only 100 meter, let's say, even
Yeah,
10
yeah, yes,
meters. Uh-huh.
yes.
This
Mm.
how our design antenna with a very small scale antenna to put our mobile device because we're thinking 6G is not base stationless, no more base station. We have to design a compact antenna to put in our device. This I think this is my idea, Professor.
Yeah, Dr. Kadir.
Yes.
Yeah, thank you, that Mr. so much for sharing that Mr. research domain where you and your colleagues in the University Islamia RIAU is that Mr. working. Just I have a very small query.
Yes,
In
sir.
60, that means you mentioned that there should be that means zero energy devices. Is it net zero energy or zero energy?
Zero energy means the device is net energy, but is the energy is not from battery like our mobile phone
Yeah,
now
so
is.
exactly. I believe this is an issue that means where the budding
Yeah.
researchers will be a little bit that means confused because no
Oh,
device can really work without any that means energy. So I
okay.
cannot that means really say that okay, the device can be a zero energy one. Rather, the interpretation should be net zero energy. Whatever energy will be consumed, the similar amount of energy can be harvested from that means the surrounding, and so therefore it becomes a zero energy device.
Yes,
Isn't it?
I agree. I agree
Yeah.
about that. Yes, because it's not zero power, but there's energy, but they're harvesting from the environmentals.
Yeah.
Maybe
So
atmosphere is zero. Yeah.
really none of the device, none of the electronics can really work at a zero power.
Yes,
Rather,
yes.
we need to that means power it up from a battery or that means certain other auxiliary sources. Only thing is that we should be capable of that means recharging or replenishing the energy by harvesting from the surrounding. So the net amount of energy in the system will be zero, isn't it?
Yes, yes, yes.
Yeah.
Exactly. Yes.
Yeah, the standing invitation that means we will be that means really very happy that means to have a collaboration with the
Yeah.
colleagues, with you as well as your colleagues in the University Islamia RIAU.
Uh-huh.
If you're that means really that means agreeable, if this is agreeable to you, then that means that surely that means we can work out the modalities and other things.
Yes, sure, Prof. Yes, thank you. Yes, we can work together later on.
Because see, because we just cannot do the research in silos, because we need to that means interact, and we need to really that means establish communication channel where we get to know from you, and that means we can also share that means what we really know.
Yes.
Yeah.
Okay, thank you, Prof. Yeah.
Welcome.
Okay. Thank you. It was a nice presentation. Thank you, Dr. Kadir.
Yeah.
With this, we'll conclude today's meeting. Thank you again, Dr. Kadir, for joining us.
Yes, thank you. Okay, my closing statement. Thank you very much again to IIT Silchar, all the professors, especially Dr. Panani, to invite me as one speaker in this session. So
you are more.
Terima kasih sudah menonton video ini dan nantikan materi menarik lain pada video berikutnya, serta jangan lupa untuk subscribe dan like. Terima kasih atas perhatian Anda semua. Wassalamualaikum warahmatullahi wabarakatuh.